Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Programmers rarely use state machines, but they are useful in certain circumstances. In the places they work well, they can make code cleaner, far easier to debug, and much easier to reason about and maintain. In this episode, we're going to discuss the use of finite state machines in your code, along with when to use them and when to avoid them. But before we get started, Will, what state have you been in this week?
State of confusion. It's the largest of the 50 states. So I have been converting code that I wrote years ago that essentially allows somebody to spin up a service to process RabbitMQ messages. And I've been porting that over to handle Azure Service Bus messages. And what's interesting is there's a lot of stuff that I had kind of built into my framework that now is taken care of by the underlying framework. And so I'm having to figure out which pieces have to be ripped out, but it's not quite the same. It's just been really different going in there and having to deal with my own code from 2014, probably, maybe 2015. So I've been doing that. I've been staying relatively busy. It's just that time of year where there's enough stuff going on that has to be handled. Plus, it kind of took me a while to catch up from all the snow and stuff and all the problems we had, from that. I haven't really been doing a whole lot of fun stuff. So how about you?
Well, I am, dealing with the minor freakouts every time I look to see how much time has elapsed and realize that we had to move our screen structure around because we're trying out the new Zencastr video recording thing. Not that we're doing a video podcast; it's still going to be only audio. Nobody wants to see that. But so the timer is on Zencastr, but I've moved it over to where Zoom was because that's where I naturally look to see Will's reaction to stuff and if he's about to speak and things. Because Zencastr won't work without the camera, though Zoom will. Go figure. Anyway, so I keep looking over to my left to see the time, and all I see is this little recording ... I'm like, oh right, I have to look over here. So it's I'm getting used to it, but it's still it's gonna take me a little bit to do that. This is our first time, a second time doing this. We tried it out when we didn't know you could still use the classic because they didn't tell us that. But
But we're biting the bullet now, so It's all good so far.
So far, so good. Yeah. I got my first assignment finished and loaded up today. Well, last night. Today. Finished it last night. Submitted it today. I mentioned, I think a month ago or more, that he'd changed the due date. So it's due tomorrow, but I finished a little early. I was actually wanting to finish over the weekend, but I just got busy. I will say, though, that make files are the devil's handiwork. Ugh.
I agree.
Also, it takes a completely different mindset to code for academic purposes versus for production. I wasted so much time, and Will got several messages about this, trying to figure out how to pass a two-dimensional array without knowing the size into a method. And then I finally realized, wait, I know the max that he's going to use for testing because he told us that. I can just hard code that in. It doesn't matter. It's not going to production. It doesn't have to be maintainable or, extensible or anything like that. And so that put me back into that mindset. Took me a little bit to realize it, but I'm better now. And then I found out because I wrote the basic code. Well, it wasn't basic, it was C++, but I wrote the code, the majority of it in VS Code, and then uploaded it to the school server where I'm, that I'm using with, like multiple cores and all that, so I can have all the threads I need because we're doing parallel programming, hence the name of the class. And once I got all of it up there and I'd done a few editing here and there, I realized, hey, they have Vim on the servers because they did at MTSU. So I'm like, I can just do this all in Vim on here and not have to worry about like, all this like upload and stuff. I'm like, oh yeah, no, boom.
Yeah, there's something to be said for that.
Oh yeah, it was quite glorious once I did that. I really like Vim though, especially when you're like remoting into a server and you can just like open it up right there and just deal with it, and then yeah, it's really nice.
And then look up how to quit.
Yeah.
It's :Q or :WQ if you want to save it,
or :X.
Yeah,
does that too. Yeah, saves and quits. So yeah, that's it was fun. I do need to print off some Vim cheat sheets because I had some the semester that I was doing stuff at MTSU and I got pretty good at it, but I don't know what I did with them. So I need to print them off again. Anyway, in better news, I got a new guitar amp. Will got to hear me play some bass on it earlier. It's a Boss Katana 100. And I believe I mentioned that I was looking at it in the aftercast last week, but I actually bought it this past weekend. It has 3 different wattage settings, 0.5, which is, what you use for in like this room here where I'm recording and stuff like that. 50 for small venues and 100 watt for, medium sized to large venues. And that was really cool. I, of course, turned it up to 100 and turned the volume up to play stuff for Will because I didn't plug the output into my Scarlett. I just had my SM58, my little small mic that barely picks anything up but my voice, listening across the room, and he could hear it clearly.
Yeah.
That was so cool. Like the whole house was shaking with the bass. I mean, it was awesome.
Yeah, I could tell you were testing your window frames.
Yeah. Yeah, it was pretty awesome. Like it was just boom. Oh yeah, that was cool. I think at about 50, it like still does that. It also has a bunch of built-in effects, and I can add more via USB. So like distortion. I know it's got a flanger on there, phaser, a lot of different stuff. And so like it's got one knob where you can just like turn to the different levels of distortion. One's really cool because like you can turn it down below clean to acoustic, and it kind of sounds like you're playing an acoustic guitar even though you're playing electric. So that's neat. And it's got some like presets, so I can do like presets and stuff in there. It's really awesome. I love it, and I am having a lot of fun playing on it. Just, I'll play a song I know and then like just switch up to one of the presets and just listen, like play it and listen to like the weirdness that comes out when I play it with like, some weird effects and stuff. It's so much fun.
Nice.
Oh yeah.
Saving money is hard, especially as we approach tax season. In fact, I just paid my property taxes today.
Ugh.
That was more than an entire paycheck.
Yikes. That doesn't surprise me. Lucas Casares is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at CDP, his focus is on helping you to not only establish a real plan for your life, but to be able to take action on that plan so that you can create your best life.
Yeah, guys. So investing in financial planning services really comes down to whether or not you can improve your finances with the help of Level Up. The compounding impact of making better financial decisions will easily pay for itself.
Yeah, Lucas provides a lot of value, and fortunately, he's got a very good, unique pricing model that will help you no matter where you are in your financial journey. So this is affordable and doable.
Yeah. He's also a fiduciary for his clients, and what that means is that he's not trying to sell a product or get you to buy stuff through him. He's there to guide you to a better financial situation.
And if you want to learn more about it and check out some of the resources he's got, you can get a hold of those at levelupfinancialplanning.com.
Often you'll run into situations in your career where part of a system will become difficult. Occasionally, an older, more experienced developer, we call them graybeards, will suggest using a state machine to more cleanly organize the code. While this approach is rather uncommon, there are times that it can work really well.
State machines are an excellent way to handle certain situations that occasionally will come up in your code. I tend to run into this a lot in UI situations where there's a complex UI. While you seldom will use a state machine, they work really well when the system has finite number of states and small number of states with clear transitions between those states. While this doesn't happen all the time, you'll often see situations, especially in the more complex UI workflows, where state machine is often the best way to organize things or an option for organizing things.
Yeah, I mean, you're not likely to use a state machine very often, though it's helpful to know when they are useful and when they're not, so that you can use them when they will be helpful and simplify things.
And I mean, someday all of us are going to be the graybeard that suggests stuff like this.
Will already is.
Well, yeah. Hey, I keep it short so that it's not gray. So in this episode, we're going to discuss state machines, when they're useful, when they're not. We'll discuss how they work and what you can expect when you use one. So we're going to start out with some definitions so that the words we use kind of make a little bit more sense, because these get thrown around a lot. And a lot of times people don't completely get the correct definition for what something is, and they think they know. So I found this especially, there's actually a note later in the outline, because a lot of what people are calling state machines isn't exactly.
Yeah, that's true. So we'll start off with, what is state?
Yeah. So it was kind of weird, trying to actually get a real definition out of like Wikipedia for this, because it's not really all that clearly defined. It's like, it's stored data, sort of. There's not really a clean one, but what they said is a system is described as stateful if it's designed to remember preceding events or user interactions. The remembered information is called the state of the system. The set of states in a system is known as its state space.
Yeah.
So it's like definition by not defining it, but by defining something that depends on the definition.
kind of. Yeah. So basically what I got out of it is, and the way I've thought of the state is the current situation that the system is in. So these flags are set, these flags are unset. This data is populated, this data is not populated. That's sort of the state of the system, or what phase it's in. Okay, we're in the intake phase. We're still gathering information. I've been doing console apps at school, so I think of a console app. So like we're still in that. All right, we're getting information from the user, and then we'll switch over to processing the information and then to returning the information.
Right.
Each one of those has a state, which is, all right, I've got this much information, but I don't have that.
Yeah, it's kind of fuzzy on the definition. This was something that was extremely irritating when I was writing this outline, because like I know what I know, but I don't have the words, and so I go try to lift them off of Wikipedia.
Oh yeah.
Because the system has a state, but that doesn't necessarily imply storage.
Yeah.
Right. Like you could have electricity going in and, this pin is high, and that's a state on the system.
That's true.
But there's not memory behind it. And so people get it confused with state, like in other contexts where there's variables. So
yeah,
when we say it, just understand that it's kind of fuzzy. And if you get to a point where you kind of have like a mild headache thinking about it, then you're probably there.
That's
sorry, that part really irritated. Like that bullet point took me 15 minutes.
I don't doubt it.
of frustration. Then the rest was easy. So a state transition.
I say it's always like that. It's like that
Yeah,
one that
there's
just
always
drives
there's
you
always
crazy.
one.
Yeah.
And yeah, I need to get a heavy bag for this kind of crap.
Yeah.
So a state transition is when a state changes in a state machine. The system is said to be going through a state transition when this occurs. State transition is the set of operations that occurs between one state and another.
Yeah.
That's what we mean when we say that. Since you're the comp sci guy, with your going for your masters now, you can describe a finite state machine.
Joy. Thank you. I didn't look any of this stuff up. I glanced at his outline before we recorded. So a finite state machine, according to Wikipedia, because Will literally quoted Wikipedia on here, is also called a finite state automaton, or plural automata. What a matter with you, automata? Sorry, I can't help it. Okay, so all that stuff, I don't know why he quoted all that, but it's a mathematical model of computation. It's an abstract machine that can be in exactly one of a finite number of states at any given time. So the finite state machine can change from one state to another in response to some inputs. The change from one state to another is called the transition, and a finite state machine is defined by its list of states, its initial state, and the inputs that trigger each transition. So,
yeah, just a note, they'll say FSM for finite state machine.
Yeah.
That means finite state machine, not flying spaghetti monster. Just to clarify for all the people out there.
Yeah. I'm reminded of, was it Discrete that we did this, where we created a finite state machine to like read a tape, and it was like one state was reading one direction, one state was stop, and one state was reading back the other direction. Let's say you just have like a strip of paper with ones and zeros on it, and because that's what we were doing. And so, you're in initial state, which is read right to left, and it just like reads 1010, and then like 10100, and that 00 is the trigger for reverse.
Oh yeah, so you're talking more like a Turing machine.
I guess. I mean,
yeah.
I'm trying to remember. It was over a year ago.
Yeah, and this is getting into a little bit more theory, but so that when we throw these terms out, it's explained. So what you're talking about was a Turing machine, which I'm going to skip to that point and we'll go back, is a mathematical model of computation that defines an abstract machine that manipulates symbols on a strip of tape according to a table of rules. This is basically the mathematical basis of computing, and it was defined in 1936 by Alan Turing.
See, I knew I read something in here. Like I told you guys, I skimmed through this quickly. I knew I read something in here that reminded me of class. That was it. I got a little ahead of myself. Sorry, my bad.
Well, it also doesn't help that the outline goes DEF instead of point. So apparently, I wasn't in too good of a state either.
Fair enough. So all right. So going back to a Turing a Turing machine is a finite state machine that meets these extra criteria. So I wasn't completely off, at least. So now that we've confused you completely, let's talk about what goes into a finite state machine. The initial state. This is the default or beginning state of the machine. So it's like when you turn it on, what state does it start in?
And the final state is the state of the machine at the end of computation. Essentially, this would be the end of a flowchart, but we're going to talk about it in a little bit. You may not actually have a final state. You may have a machine that just, once it spins up, it runs forever.
Hey, here's a thought.
A theoretical one.
Here's a thought for you to maybe understand this, because it just popped in my head, and I might be completely off, so you might correct me on this. But I was just thinking about, nobody watches cable anymore, but an old TV that had cable or whatever, where you had channels. Your initial state would be the channel that it's on when you turn the TV on. It can only be on one channel at a time, and there's a finite number of channels depending on your service provider. And so each channel would be a different state. And the ending state, the final state, would be the channel that it's on when you turn it off.
Or the initial state would be the channel that it's on when you unwrap it from the box. because from then on it's got storage.
You're going too deep on
I get
that.
where you're going.
Yeah.
I smell what you're cooking.
Yeah. I'm just using it as a light example. You're going deeper than I'm trying to go on that. But yeah.
Because I'm an awful person. So an event is basically raised when a state transition occurs. I was kind of saying a callback raised, but that's basically it notifies that something has happened.
Yeah.
A state transition has changed so that a consumer can deal with it. So it might be a callback, it might be a signal on a wire, it might be any number of other things.
Mm-hmm. Yeah, the light on the remote blinking. You never know. Sorry.
Like the person in the house next door yelling because you turned the volume down on their machine too.
There you go. Yeah. So we've already described a Turing machine. Turing completeness. Now, this is the ability of a system of instructions to simulate a Turing machine. A Turing complete language, or a language that is Turing complete, is theoretically capable of expressing all tasks accomplished by computers. And just about all programming languages are Turing complete these days, if the limitations of finite memory are ignored.
Right. And you can't ignore them because Microsoft does with Teams. Seriously. My fan will spin out and it sounds like a weed eater starting. And it's like, oh, it's Teams using 100% of CPU. That's fantastic.
Yeah. It's not as bad on the Mac,
so
but, Apple doesn't allow them that.
Many things aren't.
Yeah.
If you can get them working there, they're not as bad. So given the whole memory thing, I'm going to tell you probably you're not going to use a state machine without memory in general purpose, programming, because we kind of deal with variables. That's sort of our job. The theoretical finite state machine does not have memory, and it's really got limited utility for most of us, except as a theoretical construct that underlies the other things. So really what you're probably using is more of a, you're going to be using memory, which makes what you're doing more of a push down automata type thing, or automaton, I guess would be the better way to put it. Because automata sounds like a, tomato with a machine gun or something.
Well, yeah. That I'm just like seeing like a little Pomodoro timer shaped like a tomato.
Yeah.
Like
your 25 minutes are over.
Yeah.
Yeah. So most developers are still going to call this a state machine because that's the part that's sort of relevant for the task at hand. Because developers generally don't assume a lack of memory on anything anymore, and we haven't for 20 years. Unless it's got to be a bad circumstance for us to start thinking about memory, at least in web dev. Yeah. And you can go to any site on the web and prove me right. They're still going to call it that. That's fine.
Yeah. So the main consideration, though, is the organization of code into states and the transitions between those states. So now we're going to talk about some indications that you might need a state machine. First off, you're working with an entity that has a status column, and some operations are locked or unlocked based on that status.
Yeah, which thankfully none of us ever run into in computing. Yeah, this is pretty common. You'll see this with orders. You'll see this with most of your system entities that you're going to be storing in a database. Frankly, there's going to be a status column to go because it's something you're tracking. You're tracking its status.
Yeah,
more than likely. You also might need a state machine if you have some operations that occur on that entity that emit events that are consumed by other parts of the system. In other words, you need to know that, hey, this order got processed.
Yeah.
Or this order was, this cart was abandoned, and you want to send an email to try to, sell them, something at a lower price so that they'll come back to their cart, for instance.
Another reason you might need a state machine is that your domain model has a lot of spaghetti code or nested if-else clauses in the code.
Yeah. And I've seen quite a few code bases that are like that. You get the Hadouken code, where it's an if statement with another if statement with another if statement, and pretty soon you're scrolling to the right to see it. Unless you're me, because if I have to scroll to the right on my monitor, I'm coming to wherever you are. I got a 50-inch screen. So,
do you code?
But I mean, you'll see that.
I want to know, do you code full screen?
Sometimes I do.
Wow. Like, I have not been to his place since he's had it. I haven't seen it. And so,
yeah,
it's
obnoxious. Like when I have to do it, it's bad.
Yeah.
And usually it's split screens.
Yeah.
With code on all of them. But yeah, sometimes I will just throw the whole thing up on the screen.
Wow.
Because I can.
Yeah. I get that. I'm just, wow. Yeah. Okay.
I'm happy to be able to do it. I'm not happy to do it.
Yeah. The other day I was coding on half my laptop screen because I had something else open on the other and I wasn't at home. So I didn't have like two monitors.
I hope someday you can lift yourself out of poverty. That'll be a big day.
Well, I was sitting at a coffee shop. What else was carry a monitor into the coffee shop with me?
Hey, you know what? That's nerd points. Take them.
Wow.
So speaking of nerd points, another indication that you might need a state machine is that you're beginning to run into a lot of errors because the system gets into weird combinations of other state that you didn't expect. So stuff is entangled. The invoice ends up in a processing state, but it's not been paid yet, or you don't know who bought it.
Yeah.
For instance, that's a bad sign. And when you get those kind of errors, you may need to start looking at this.
Yeah. It sounds like a issue with the asynchronous processing there. Like you send it off.
Yeah.
And then you go on and you don't like wait for it to come back before you make those changes. So yeah, I can see why like that, how that state, like a state machine there would make a lot of sense. Not because I haven't, had to deal with that kind of issue recently.
The last 4 hours.
The other one on here is you can't transition between certain states because there's no reason to do so. I didn't understand this point, so I don't know why I ended up reading it, but could you explain that?
Okay. So let's say, I don't know, we'll go with the invoice processing thing. Somebody, or they put an order in. Let's say we'll do order processing. They put an order in. They don't cancel it. It's not delivered, but it's considered finalized. So like they shift from I haven't paid to it's delivered, essentially. That doesn't make sense from a business logic perspective, unless you got free stuff and then you're doing that. But even then, the state of delivering is still going to be a step in there. So it's basically where you have a sequence of states, but you can't go from any given one to any other given one. Or you can't go from, hey, this was delivered and paid for to, oh, it's pending. It's still in the cart. Because that's going backward on the state chart. That doesn't make sense. So when you have those kind of flows, this can often work out well for you. Another reason that you might need a state machine is if you have all these things going on and this is kind of a fixed piece of code that's not very likely to change as a result of project plans, market changes, those kind of things. Like it describes physical systems.
Yeah.
Typically. So like we have a thing at work where you calculate pledges to give to a church, right? So they can go in and they can say, I want to give $1,500 over 3 months, weekly donations. It'll break it down and say, here's your installment plan. And you can say, I want to give this much up front. Like the logic for how all that would be calculated, the length of a week isn't going to change, for instance. So that's a pretty good use case for a state machine. Now, I also know that my team lead is probably going to listen to this episode. And I also know that he probably didn't implement it as a state machine. In fact, I know he didn't because I just reviewed the PR. But it would have potentially been a case that this could work for.
Yeah. I see what you're saying there. So now that we've talked about why you would want a state machine or the times where you need one, let's talk about some times not to have a state machine.
Yeah. And the first one is, why do you not want to do anything? And that's when you have a volatile domain. So the business changes their rules frequently. So we're not talking like the speed at which like governments change tax laws, but you've got some guy that's in a corner office that said one thing yesterday and says something different today, and you've got to code it.
Yeah.
If you're subjected to that in that part of the system, a state machine is probably not going to be a happy place for you.
That sounds miserable with or without a state machine.
Another case would be when you have a large or infinite number of possible states. Sometimes this can mean that you're not thinking about the states properly, but there are cases where, if you're getting to the point where you have like 100 different states, that's either multiple state machines or it just isn't one.
Yeah. I follow that.
And I haven't really worked with a whole lot of stuff like that, but
another one kind of similar to that would be if you can't break your code into discrete states.
Yeah, because multiple things are going on at the same time, which is the next one, right? Like if you want to execute several states in parallel.
Yeah.
So with the order processing example, if you're doing stuff like, hey, I want to pre-pack the box while their stuff is still in the cart, because, we pride we're Jimmy John's and we pride ourselves on fast delivery. And so we're going to go ahead and start making the sandwich before you've actually paid, because we know that we have a 98% conversion rate past this point, and we're just willing to just eat the extra sandwiches.
Literally
doing these things in parallel, right? Like companies do this kind of stuff.
No. I was just being silly.
And I would really like a sub.
Yeah, I can tell. No, so here's what I was thinking. I was thinking our Kanban board.
Yeah.
So we have discrete states from idea to up to the point that it's recorded. At that point, it splits because we send it off to get edited. So that is one process. I work on the show notes. That's another process. Once it gets edited, I have to put those two together and put it on the website. Will used to write an email, so that was another process. We don't really do episode emails anymore because they just, honestly, we found them to be annoying for ourselves, and we're like,
nobody would open.
If we're annoyed by them, then you guys are annoyed by them, so we stopped.
Yeah, and I mean that's a good case for actually having sub state machines.
Yeah,
that when they're all done, the containing one switches to a different state,
right?
Which is a lot more complex orchestration, but it's definitely doable.
Yeah.
Another one is when your code is just too simple to justify the overhead. Frankly, a login form, everybody knows how those work. You can do it as a state machine. I don't know why you would, because like any sample code that you could just look at on the web that you're probably looking at and going, yeah, that sounds like a good idea, I'll do that, is not going to be a state machine.
The only time to do a state machine on simple code is when you're in school. And
I was going to say, it's called college.
Yeah. It's like, the program that I did was matrix multiplication, just straight up linear algebra, matrix multiplication stuff. The not difficult code, not even that difficult to run serial, but the goal of it was to practice what we had learned about parallelization. Parallelization? Is that a word?
You feel like your tongue is like doing parallel execution when you still say parallelization. Have you ever noticed that?
Yes.
Like one side wants to go one way. Really hard word to say. So the final case of when to avoid a state machine is when your coworkers just are not going to understand it and they're going to rip it out when you're gone. This has happened to me. There was some code that I wrote that was very clean, very stable. A junior dev kind of went in behind me, ripped it all out, replaced it with a whole bunch of if statements nested deeply, and it's a pile of crap now.
Why did they do that?
Because they had to add something to it, I think, and they couldn't comprehend what it was doing. And even though they could just call me, they didn't. They just ripped it out. And then I heard about it from the rest of the team, which I found infinitely amusing.
Especially because you didn't work there anymore.
Oh, yeah.
That's the best. That's the best when you do something very, very creative. And then, yeah.
Well, now it's not my fault. Anything else that happens to it, it's been touched and I know.
Yeah.
That's all I wanted, really.
So now that we've gone through all of this, like these like Wikipedia definitions and the whys and why nots, let's finally get into what you really want to hear about. And that is an example of a state machine.
Yeah. And for this, we're going to say that it's a vending machine from the 90s where a Coke was 50 cents or a Pepsi was 50 cents. The machine only accepts coins. It'd be nickels, dimes, and quarters.
No pennies?
So it's you. So
no
what?
Pennies?
No pennies. No pennies.
All right. We're describing this in United States of America terms because that's what we know.
Yeah, right. And it's a Pepsi machine. If you're an Insane Clown Posse fan, it's a Faygo machine. We're fine with that. Now let's move on. So the machine has an initial state of accepting payment or awaiting payment, however you want to call it, which means that you can't select an item to vend. And if you pull the switch to say, hey, give me my money back, you don't get anything because there's nothing in there.
As you add money, the machine goes into a continue accepting payment state until a total of 50 cents is placed in the machine. Note that during this state, you can initiate the refund action, which will zero out the amount of money and return the coins to you.
Unless it's like 90% of the machines in the 90s that wouldn't return you your money, but would zero out the amount anyway. Once the 50 cents is reached, the machine enters a dispensing state where you're allowed to make your selection. Once you've made your selection, the machine enters the vending state, dispensing your drink. At this point, 50 cents is subtracted from the total amount entered. If this comes out to zero, we return essentially to the initial state. If not, we go to the give change state, dispense the remainder of the coins back to the user, and then return to the initial state. So you can kind of see the flow chart there, right?
Yeah.
Plus, you've interacted with a vending machine, so it makes sense, hopefully.
Now, understand this is very simplistic and not adjusted for inflation. Though, hey, was it like 2 or 3 years ago? I don't know where I was, but I ran into a vending machine that still was only 50 cents. I think it was like behind a factory or something, where
or like a tire shop, where they're they're supplying that to the employees and they're not trying to make money, and you just happen to walk into the break room.
Yeah,
because those will still be about that price.
Mm-hmm.
Otherwise, no, that's long gone,
sadly.
So let's talk a little bit about how to actually implement a state machine successfully in a language agnostic manner. Your language is probably going to have constructs that make some of this easier and possibly have constructs that make some of this harder.
Yeah.
Depending. First of all, this is typically done in a not entirely agile fashion. This means diagramming everything out beforehand and actually planning ahead. So shooting from the hip on a state machine doesn't really work very well. Like you probably need to actually break down the interactions. State machines are extremely annoying to do in an iterative fashion, and debugging can become kind of obnoxious if some of the invariants with the system change while you're building the system.
Yeah. I mean, you could probably do this in a pseudo agile fashion where you plan out the states and then the stuff that can change within them. You build it iteratively, but a lot of it's planned out. I've seen that before.
Yeah, this is one of those spots that Agile runs into problems, and a lot of it is just people haven't done a whole lot of this in an Agile fashion, and so there's not blueprints in people's heads for how this works. Yeah. But the goal of the design is to limit the state machine to a few distinct, non-overlapping states with clear transitions between them, which means you need to be clear up front about what you actually want.
Yeah. State transitions need to be defined as things that either occur automatically within the system or as a result of user input. They should be unambiguous and easy to define once they've occurred. That way the system can process it.
Yeah, it's sort of like actually writing code for something.
Yeah.
In that sense, right? Like, people tend to kind of miss out on that and go, okay, we can make things a little fuzzy here. It's like, it's not going to work so great on state machines. You have to be especially careful about workflows that could place the system into a non-working or invalid state. You have to actively guard against this using validation logic, essentially, or go, hey, this state transition is not available from here.
Yeah.
Because, that's really what you're trying to do. That's the whole point of the exercise. It's generally recommended to put a lot of tests around any implementation of a state machine, both to verify correctness and to help future developers avoid major system problems. Because we know this thing is going to change probably at some level at some point, and you really want exhaustive tests around the rest of it so that it doesn't get pushed out into production later. Because what will happen is it'll break, and then it's a little harder to debug sometimes, especially if you didn't write the thing initially.
Mm-hmm.
And so the tests will kind of help protect you against that.
Yeah, I think I've told you guys about the developer I'm working with. He's been doing MVC for so long. You just can't really do unit tests well with MVC. So he hasn't. Different type of testing, but just not unit testing. So we had a call earlier today where he wants to learn unit testing. And so he wrote some practice tests, mostly from looking at some code that I'd written, very similar to what he's doing. And so we hopped on a call, and he was just like, I just don't understand it. Like, we're testing this like one controller method, and he's like, all it does is call into the service and then return what comes back. And that service goes out and does stuff, but like all we're doing is testing that it's calling the service. I was like, yeah, it's not like, we pretty much know whether or not this is going to work. It's not to see, is our code working? It's for when someone comes in 4 or 5 years from now and they make a change, so that they can make sure that they don't break everyone calling into this API. And he was like,
Right.
oh, that's really useful. I'm like, yeah, now you see why I'm like all gung ho about doing unit tests. He's like, yeah, I do.
It makes phone calls not happen. Yeah, and you're typically not going to do this for transient or easily changed business processes. This tends to be more around, critical processes, things that are performance critical. They're tied to the real world in some way versus fuzzier kind of things, I guess is the best way to put it.
Mm-hmm.
So speaking of what it's actually tied to, let's talk about some common use cases where you will run into state machines that other people have written, or where you might want to write them yourself. And probably the most common that I've seen is complex UIs. So like if you're implementing things like wizards or complex onboarding workflows, you'll periodically run into implementations that use one or more state machines to try to control that complexity. Because if you have like a 15-step wizard and there's a whole bunch of inputs that get hidden and shown and potentially on different screens based off of what you picked in the previous, it's hard to manage one of those without something like this. Now, they may implement it poorly and it may not quite be a state machine, but it'll be in the spirit of one.
Yeah, I've seen this in Angular.
I've done it. Yeah.
I wasn't even the API developer on that project. I got pulled in when the API developer left. He got a job in another area that basically it was a promotion by leaving kind of thing. That's common. Nobody thought bad about it, but I stepped in and helped finish that up, and that was an interesting one because it was a process that was like filling out this form that, all right, because they were trying to digitize it. It's like, okay, well, if this is the case, then you also fill out these 4 other forms, and they wanted to include those. But if it's not the case, then you fill out these 3 forms, and it's just like
it gets awful pretty quick. So complex UIs are a place that you're going to see this a lot. You'll also see it a lot of times with more low-level implementations of UIs. So like if they're doing, Windows development with MFC, a lot of those folks that develop that kind of stuff, they kind of have more of a deeper understanding of state machines and the kind of stuff that goes on there just because of their programming model. And so they'll use that. Another place that you'll see it is network-oriented code. So like if you're dealing with network connections, especially at a low level, so like you're opening sockets or you're dealing with serial input is a great example of a place that state machines are wonderful. You'll find these things are kind of helpful. So like you might have different states for connected, disconnected, transmitting, or if you're kind of establishing a connection and there's a protocol going over the wire and you can't send certain kinds of data until the connection is established, you'll run into this.
I tend to use the spoon protocol for serial input.
Yeah. I haven't had to do serial in a while. I've had to do some socket-based stuff.
Sorry.
The fall before last, I had to do socket stuff, and that was not entertaining at all.
So another common place where you will see this is in payment processing or related to that order tracking systems. Payments and orders tend to move through a number of phases during their lifetime. During this, some operations are valid and some are not. they also tend to be fairly complex due to the inherently complex systems that they're in. Like, just the processes are very complex. I'm just thinking about like some issues I've had to assist with on our payment processing, and we're using a third party, but just on the process of going to them so that we don't have to like maintain any PII from it. So like going to them,
Right.
personal identifiable information, PII. Like
Yeah.
going
PCI compliance is something to avoid.
Yeah. Going.
Yeah.
Well, you don't want to avoid compliance. You want to be in
you want it to be somebody else's problem.
Yes, that's why we do this. But it's like
probably a better way to put it.
Sending them to the third party to run the payments, and then getting that information back, and then like the whole process. And the whole time we were talking about this, I was like, yeah, I've already thought that once we get the system that I'm building now built, I'm gonna like push for, hey, can we fix this other system and get it running more smoothly? And the payment processing system is the next one I want to work on. I'm like, state machine.
You might change your mind on that, but I worked with a lot of payment systems. It's not my jam. I know people that like it.
I'm not saying that I'm not wanting to do it because I will enjoy it. I'm wanting to do it because it will give me less of a headache building other things.
Yeah, I get you. It's still not as, however much fun you think it is, it's less than that.
I never said anything about being fun.
There's an asymptote there that you'll get caught under big time. No. But another place you might use this is a situation where you're interfacing with a mechanical system. Mechanical systems take time to respond because, physics, and they're kind of under real world constraints. So like things like safety constraints, you can't turn the laser on while the hatch is open because, the technician may be reaching in there doing something and you don't want to cut his arm off, which you probably can't with a typical laser, but you don't want him to get a bad burn. If it smells like chicken, you're doing it wrong.
Wow.
So you're going to want to have setup that basically says, hey, this action cannot be performed when the system is in this state.
Yeah. What was with
physical systems? This is common.
The guy in, was it Russia, I believe, who was like working on a particle accelerator and it turned on and shot through his head. He lived. They've done all sorts of studies on him, but yeah, I read about that.
Any superpowers?
Not that I know of.
He lives in a superpower. So there you go.
Wow.
Yeah. So do be aware though, as far as like physical systems or mechanical systems, have actual physical checks in there besides just the software ones. There's a very unfortunate incident we'll discuss sometime in detail, the Therac 25 incident, where they had a software check and they didn't have a hardware check when they really, really needed to have one, and it involved radiation, which is always a good time to have a hardware check instead of just software. So yeah, that was pretty bad.
Yeah.
You'll also see state machines sometimes when you're doing heavy string processing. Regular expressions describe patterns, for instance, that can be recognized by finite state machines, and you'll do a lot of this stuff in school. Mm-hmm. So if you're ever implementing your own regex engine or anything like that, you might actually use these as well.
Right.
So I guess we should probably talk about, real quick about UML state diagrams. So what a UML state diagram is, and this information is from visual-paradigm.com. A UML state diagram is typically used to show state-dependent behavior for an object. So a state is considered to occupy an interval of time, during a process.
And UML stands for Universal Modeling Language.
Right. I always forget that. I don't know that I've ever heard anybody actually break that down in a conversation.
It's not really a conversation so much as a education.
It's discipline. When the UML comes out, it's you're either in a really good place or a real bad one. There's no middle ground.
Yeah.
So a state is often associated with an abstraction of attribute values of an entity satisfying some conditions. So one or more pieces of data on there make up the state.
So an entity changes states as a consequence or a result of an input, but it's also dependent on some of the past properties of its previous inputs. So that's the state. Those past properties are sort of the state.
UML state diagrams model initial state as a solid circle and use arrows for state transitions. States are then denoted, real states are denoted with a rectangle. The initial state is the first state, following the arrows after the initial state. So basically, like after it opens up, it says initial state twice in that wording. You have like a starting point, and then you go to the first state.
Yeah. So like
what I was trying to say there.
If we're using the
it's the one based index instead of zero based.
Yeah. Well, what I was saying is like if we're using the TV example, the circle would be turning the TV on. That goes into like turning the machine on is the circle that leads to the initial state, which is the channel that it's on.
Well, and one person's initial state is another person's.
Yeah. Or using your vending machine example, plugging the machine in.
Right.
Is that circle. That leads to the initial state of, accepting money.
The final state is then denoted with concentric circles. Sometimes a state machine does not have a final state. In this case, it loops back to some prior state and continues execution until the system terminates. So like with the vending machine, once you get a Coke out of there, the next dude should be able to get a Coke.
Yeah.
Right. Like it hopefully doesn't terminate and die, because that makes the ball game bad.
State diagrams are a logical view of the totality of the state machine's interactions. It's a way of looking at like kind of an overview of what all is supposed to happen.
Right. And the other nice thing about it is you can show it to somebody that's not a developer and they can follow it.
Yeah.
Which contrasts with some of the other ways that state machines might be diagrammed. You'll see sequence diagrams used by software engineers, and they show typically a single set of interactions rather than the full scope of what could happen. So you're trying to handle a particular process, like how something goes into the system, for a declined payment on an order. What happens when this goes through? So you can kind of follow it. I neglected to try to describe this on the air because I think people might fall asleep in their car. They're useful for troubleshooting why a particular set of interactions doesn't make sense. I do not like using these.
Yeah.
Personally, I understand them just fine, but I look at it and I go, okay, if I have to show this to a project manager who's not like a real, like trained in dealing with this, or I have to show it to a business person, I don't feel like I can translate this into English. It's great for software engineers, but we need to keep this to ourselves.
Yeah.
Is generally the feeling I have on that.
Sometimes you'll see state machines diagrammed using old school flowcharts. This doesn't show them well, but a lot of people understand flowcharts. So it kind of has the opposite problem of the previous one, where it doesn't do a very good job of describing it, but everybody seems to understand flowcharts. Like within.
Yeah, it's also fun too. You get a developer that will do something with a flowchart and they've actually invented a state machine. It doesn't click until you go, wait, that's a state machine, what you're doing. Because it's a solution that you back into.
Yeah.
In probably a third of the cases, right? And so you'll see this a lot. Mm-hmm. Another one that you'll see that is probably, I don't know if it's the least fun or the most fun. It kind of depends on how much you liked math problems in school, particularly word problems. You'll also find that people describe state machines and their workflows without using diagrams at all. Rather, they do this in a narrative fashion. This happens and this happens, either with bullet points or, whatever. It's the business person kind of breaking down how the process works.
Well, isn't that...
and this is how normal people talk.
Isn't that what, like, the whole Gherkin language was based around?
Yeah.
The given, when, then. Like, it's like...
Yeah.
Given these inputs, like, given this is the scenario, this is your machine, when you have these inputs, then you're in this state.
Yep. And that's probably one of the better ways that happens. What typically happens is somebody just, core dumps what they know about the process to you verbally, and you deal with it. And hopefully you got it recorded so that you can listen to it again.
We've actually been having some issues. Well, not issues, but a situation where our customer used to be one of our developers who kind of got promoted by leaving and is now like their business architect person. So he knows us really well, but then our business analyst is like, well, you, when you were here, helped design what we're building now. So it's like, there was like this, all right, well, we don't really need to put a whole lot of information in there because the developers know what they're doing and you know what you're building. And then we get to like our first review, whatever. And it was, hey, I don't have any like criteria to say this is working or this isn't. And it's like, okay. So I sat down with the BA because I did help to design some of it. And we just came up with a very loose, gherkin given when then, and then just bullet points on the kind of the state, basically like on success, you'll get this. Like, and like most times you just have one like success criteria, but sometimes it's like, all right, if like, let's say you're getting back a certain amount of information, like on success, if you only pass in one, you'll get a single. If you pass in a list of IDs, you'll get a list of results back, kind of thing. And then on error and like, what the error states are and what they're going to be. And oh my goodness, no joke. We brought that into the next meeting and world of difference.
Yeah. I wish developers in their training, of course, I'm also dating myself by this because it may be a thing now, like actually had to convert those, because that would like take a narrative, convert it into a state flow.
Yeah.
Because it would be so helpful. So guys, state machines are not always the right solution to complex software problems, but they perform remarkably well when they are the right solution. However, if you didn't have formal computer science training of some sort, you may be a little confused by them when you first look at them. That's okay. We kind of hope this breakdown is enough to let you discuss them intelligently with the more comp sci nerds on your team that probably have had more exposure than they need. What is the LD50 on that anyway? They can be really useful at times, but they do have their limits. It's important to understand these limits when attempting to use state machines to simplify your code. Furthermore, if you haven't had a actual comp sci education, you're actually more likely to understand these limits than a lot of the comp sci folks, because you're going to slam into them first. And that pretty much wraps us up. Beej, what do you have for us this week for tricks of the trade?
So sometimes we can think of our lives as various state machines. Like, for example, within your career, you may have the state of junior, mid-level, senior, lead developer. And each of these has its own roles and responsibilities, your own transitions between them. However, to move from one state to the other, like for that transition, it's not a new input. It's not your boss says, hey, you're getting promoted. A lot of times it means taking on the role and doing some of the functionality of that higher state while you're still in the lower one. So, to prove you're ready to be a senior developer, you take on a lot of the work of a senior developer at mid-level. To prove you're ready to be a lead, you start doing more leadership things when you're a senior. You could also think of this in terms of relationships. You have the boyfriend-girlfriend state, the fiance state, the husband or wife state, and for some, the Texas state or the X state. All my exes live in Texas. Will got a confused look on his face there. While machines...
That's my resting state.
While machines have definitive... Confused is his resting state, not Texas. While machines have definitive lines dividing the different states, in reality, people don't have these very defining lines. It may be a good model for describing something. It's not the way people are going to work. So what I'm getting at here is just don't try to put yourself into a state model or a box. Don't box yourself in with it.
So you're saying don't try to pretend to...
So that's pretty much all I've got. Guys, if you want to hear more, and not just more about state machines, but more about all sorts of other stuff, check out the Aftercast on Patreon. It's a $5 donation will get you access to that. We produce one for every episode, so it's really awesome, and you should totally check it out.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.